something that is worth noting here. The English names at this point become formulaic. This is true, but also, as I noted, there is a point further on where we have to add new names like 100, 1,000, million, billion, and there is a point at which those names run out. So, as far as English naming convention goes, you cannot count infinitely. So, as far as English is concerned, there is not an infinite number of these things. If you want to call these the natural numbers, that's fine, but it doesn't go to infinity in English. It doesn't go to infinity in any natural language. And in English, it goes further than it does in most languages, honestly. But you can look at Roman numerals. It terminates at some point, fairly low point actually. So it is not actually the case that there is necessarily an infinite number of numbers. It is not necessarily the case that this is a countable infinity, because, as I noted before, counting is stepping through the number names. If you can't name them anymore, you're not counting. And this actually extends even, say, to like a decimal representation of numbers, a decimal expansion or something, however you want to call that. So like the way that you would normally write out numbers with digits. You can go very, very ridiculously far with that. But, say for instance, you dedicated this entire planet to writing out one number. There will be a point where you run out of room. So we're not even considering problems of time or whatever, how long it might take to affect this writing. We're just looking at space. Okay? So on this planet, once you finish writing it out, utilize the entire planet, and you still have more number to go, what is the protocol? Do you now go to Venus? Do you now go to Mars? And say you establish a formula for continuing to write this number out across every object in the solar system. What is the protocol from there? Where do you go from there? Do you go to another solar system? So even with a decimal expansion, where it appears to be unboundedly formulaic, it actually isn't. So there really isn't an infinite number of numbers. And I think, who was it, Poincaré, was concerned about this. And I feel like he was correct. That there Peano and his cohort were claiming that this would work, but I don't see that it can. Just because you're incrementing doesn't mean you're counting. You have to be able to name the number that you're looking at. And if you don't have a name for it, and then all of the numbers up to it, then it isn't counting. So there becomes a point where you can no longer count. And it's not even a matter, it's not a problem the way it's normally construed. It's not a problem of time or of, say, the particles in the universe. Because you don't even have a protocol to grow your number larger than could be written across this entire planet. If you need more space than this planet, there is no formula to go larger than that. So you're done. You're done at that point, objectively. And if you do establish such a formula, that's a different number system than what you were using originally. So the number system that you have now can't do that, guaranteed.